diameters, or 1.5 millimeters, whichever is larger. As you can see, the insulation clearance in this example is excessive and should be corrected before we solder this connection. Now we'll place the properly stripped and pre-tinned wire into the cup and secure the wire using a third hand tool or equivalent. The conductor should be fully inserted into the cup, touching the back wall for its full length. Next, we'll place a large, clean chisel tip against the back of the cup to transfer heat into the terminal. Then we'll insert the solder wire into the cup opening against the back wall to form a small fillet between the back wall and the wire. In the final step, we'll move the solder wire to the center to avoid touching the left or right edges, minimizing the chance of spilling over as the cup fills with solder. The solder wire and the soldering iron tip are then removed from the cup at the same time. It's important to leave everything still until the solder solidifies. If excessive solder is used, it will spill down the sides of the cup. If insufficient solder is used, the solder connection won't have the required mechanical strength. At this point, we'll clean off the flux if required. Here is what the acceptable solder joint will look like. The wire is fully in the cup, and there is an insulation clearance from the top of the cup to the insulation of the wire. The solder contains no dips or recesses within it and hasn't spilled over and down the sides of the cup. Also, check that there is no buildup of solder on the cup where the soldering iron made contact. If there is a small quantity of external solder, it should be a smooth film with no bumps. When the solder volume is correct, the fillets are slightly concave and show good wetting on all the surfaces. Unlike the other terminals, the outline of the conductor is not required to be visible inside the cup. When there is insufficient solder, the connection may not have acceptable mechanical strength. When excessive solder is used, solder buildup on the outside of the cup may negatively affect the form, fit, function, or reliability. In situations where the cup terminal is inside a connector, the soldering operation is much more difficult. The area you'll be working in is considerably smaller, and there is the danger of possibly burning or damaging adjacent wires. In this case, a resistance soldering tool can be useful. This tool contains a pair of electrodes that can grip the cup and send electrical current through it. The current will heat up the metal and melt the solder. The manual for the resistance soldering tool will specify the correct setting based upon the type of terminal you're soldering. The advantage of this tool is that the electrodes can be positioned before the heat is turned on. That means you won't accidentally heat the wrong area and possibly cause damage. The cup is gripped with firm pressure and a foot switch is depressed to start the heat. Insert the wire, press the foot pedal, and feed in the solder. Then, release the foot switch. After solder solidification, remove the electrodes. The foot switch should always be released before the electrodes are removed to prevent arcing. Electrical arcing could damage the plating on the terminal. Now let's take a look at bifurcated or forked terminals. On these terminals, the wires can enter from the side, the top, or the bottom. Side entry is commonly used when one or more wires are connected. The recommended minimum wrap on a bifurcated terminal is 90 degrees. 180 degrees is used when additional mechanical strength is desired and when there is sufficient clearance between adjacent terminals. When 2 or more wires are required, they should be wrapped to alternating posts. Let's watch the soldering operation for a side route installation of 1 wire. The pre-tinned wire is laid across the terminals to determine the proper insulation clearance. A 180-degree wrap is made using pliers that won't cause damage to the wire. The wire is now positioned and trimmed so that it doesn't protrude more than 1 conductor diameter beyond the edge of the terminal. We do this to make sure the conductor doesn't violate electrical clearance and cause a short circuit. The wire should be mounted at the bottom of the slot, between the terminal posts. Now, place the solder wire in contact with the terminal base and the wrapped wire. Next, a solder heat bridge is made. Remember, the purpose of the heat bridge is to transfer the heat more quickly to the connection and to preheat both the wire and the terminal so they are hot enough to melt the solder. Then the solder is touched to the other side to form a proper solder fillet. After the right amount of solder is melted, remove the solder wire, followed by the iron. Let's watch these steps once again in real time. The joint can now be cleaned, if required. The acceptable joint will have a concave fillet between the wire and the terminal. It should be smooth, clean, and display evidence of wetting. It's recommended that the wire should be in contact with all 3 terminal post surfaces. Here's another joint that has insufficient solder and may not have acceptable mechanical strength. Also, notice that the wire is extending beyond the edge of the terminal more than 1 lead diameter, which is not acceptable. This joint has excessive solder. The fillet bulges out, and the outline of the wire is covered by the excess solder. In addition to side entry, wires may also enter from the top or bottom. For top entry of bifurcated terminals, the tinned wire may be bent to double thickness, thereby contacting more surfaces for a stronger connection. Once properly inserted, the wire is soldered. If the wire is too large for double thickness, a filler wire is cut to length and added to fill the space. For bottom entry, the wire is bent a minimum of 90 degrees from where it comes up through the hole. The wire should then be trimmed so it doesn't protrude more than 1 wire diameter beyond the edge of the terminal. Make sure the wire insulation does not enter the hollow terminal. Next, we'll look at hook terminals. Hook terminals are found primarily on hermetically sealed relays. The wire wrap should be at least 180 degrees. Numerous tools can be used to make the wrap for hook terminals as long as they don't nick, scrape, or leave impressions on the conductor. One example that we'll use here is round nose pliers. Now let's examine how hook terminals are soldered. Once the wire is pre-tinned, formed, and attached to the terminal and held in place with a third hand tool, the solder wire is placed in contact with the terminal and the wrapped wire. Next, a solder heat bridge is formed. Then, the solder is moved to the opposite side of the fillet area. After the solder flows over the wire to form the proper fillet, the solder wire is removed. Then the iron is withdrawn at the same angle it was introduced to the joint. Last, we clean off all flux if required. The acceptable solder joint will have the same characteristics we've seen so far: slightly concave fillets and evidence of good wetting. Here are two unacceptable solder joints with insufficient solder and excessive solder. The last terminal we'll be soldering is the pierce terminal. Pierce terminals have a hole in the middle. The hole may be circular, oval, or square. Wire can enter from either side or from the top. The pre-tinned wire should be mounted through the hole, then wrapped and positioned to contact both the flat sides of the terminal and held with a third hand tool. Let's watch the proper soldering operation for pierce terminals. Notice that it's the same basic procedure we've seen for many of the terminals. Remember the 4 basic steps of the soldering operation. The solder wire is placed at the point of greatest thermal mass, in contact with the terminal and the wrapped wire. Additional solder is then applied on the opposite side of the contact point to form the necessary solder fillets. The solder wire is removed when a sufficient amount of solder has been added to the joint. Finally, the iron is withdrawn at the same angle it was introduced to the joint. Then the flux is cleaned off if required. The target joint will have a concave fillet between the wire and the terminal. It is not necessary to fill the hole of a pierced terminal with solder. The solder fillet only needs to be between the wire and the flat surfaces of the terminal. It should be smooth, clean, and display evidence of wetting. When there is insufficient solder, the joint may not have acceptable mechanical strength. When there is excessive solder, the fillet will be convex and the outline of the wire will be buried in the mound of solder. This is undesirable because the excess solder can hide defects in the connection. As you've seen, there are many different types of terminals and wire positioning arrangements. But the same soldering procedures apply to all. We've shown the methods for soldering turret terminals, cup terminals, bifurcated terminals, hook terminals, and pierced terminals. Terminals are part of our everyday lives. When we turn on our electronic products, we are relying on someone's careful assembly of wires to terminals somewhere inside the chassis. It's important to always do our best quality work.
Take it from Dr. Solder. Your skills can make the difference between a happy customer or the other kind. Now, make 2 solder joints and call me in the morning.